Sasha, come here. Come here, little one. Come on, little one. Come here. Come up here, little one. Come on. Come here. Come here. Come here. Come here. Come. Come on. Come here. Come here. Oh, fine. Hi, everybody. How are y'all doing today? How was your weekend? Hopefully it was a good weekend for all of you. Real quick, can you give me a thumbs up if you can hear me? Okay, I want to make sure that's all working. Actually, it's not working yet. All right. Can everybody hear me? Okay, now in the sound, is the sound kind of echoey or is it not? Somebody write echoey or not. I have a feeling I goofed up on how I set up today. Okay, good. So I don't know if it's working with my microphone or if it's actually not working with the microphone, just by the way that I kind of started things today. So either way, we should be good to go. All right, so welcome everybody. You're on your day of a test here. So it's our wonderful day of giving. So I get to give you a test, you get to give me a completed test, and we're all good to go. So with that in mind, I would like to know if anybody has some other questions on things that they would like to take a look at, either from the review, previous questions, previous assignments. We can take a look at concepts. So if it's a concept, try to leave me a message of some sort as to what you'd like a little coverage on. Or if it's a problem number, page number, whatever the case may be, let's go ahead and get those coming up in the comment section. We'll get started. Okay, so I'm waiting on all you. There we go. Okay. All right, so Zaria, you're looking at problem 59, Blessing, page 632, 635, problem 51. Okay, so Zaria, if you can respond, what page number? Are we looking at the review or are we looking at a previous page number? While you're doing that, I'm going to hit Blessings, problem 51 on page 632 to 635. Okay, so I'm looking at problem 51. All right. All right, so in problem 51, we are looking at an amusement park ride, a velocity v in meters per second of a car moving around the curve with a radius of r meters. Is going to follow a formula here. Is equal to the square root of a times r, where v is velocity, and that velocity is listed in meters per second. The value of a is an acceleration. I think I've done this one. That's meters per second squared. Okay. And so in this case, and then they're saying that r is equal to the radius in meters. Okay, so I'm putting my labels in behind there. So in part A, it says, for safety reasons, a ride has a maximum acceleration of 39.2 meters per second squared. If the cars on the ride have a velocity of 14 meters per second, what's the smallest radius that the curve can have? Now, in this particular case, because we've got some decimals in here, we're probably going to be able to go and use the calculator here as we work this through. So I'm going to go ahead and put in the values that they're giving me for part A. So they're saying the acceleration is 39.2. We're looking for the radius, but they are giving us the velocity of 14. Okay, so plugging in my values for part A, this is what my equation would look like. So from here, now I'm going to go ahead and solve it. So I have to eliminate my square root. So I'm going to square both sides. And in doing so, I'm going to do 14 squared. So as I consider that, again, I'm pulling out a calculator because I don't have these all memorized anymore. I'm getting old. I get 196, so I can clean that one up pretty quick. So I'm going to get 196 is equal to 39.2 times r. So all I have to do to finish here is just divide by 39.2. Okay, so I'm going to take 196, divide by 39.2, and that will be the radius in which I'm needing. So I'm dividing that result by 39.2, and I come up with an exact value of 5. Okay, so keep in mind, want to make sure that I've got a label with it. Radius is in meters, so I need to know that my radius is then 5 meters. Okay, so there's part A. Now, part B on that one, it says, what is the acceleration of the car moving at 8 meters per second around a curve with a radius of 2.5? So in part B, what they're doing is they're just changing the information. Okay, so in part B, again, starting with the same formula, they're now giving us, in this case, moving 8 meters per second. So that's a velocity. So I'm going to have 8 meters per second there. And they're then asking with a radius of 2.5. So under my root, I'm doing a times 2.5. Okay, so recognizing my pieces of information helps by knowing labels, because that tells me then a little bit more where things go. So in this case, what I'm going to do is take my square root, or excuse me, take my square to both sides. 8 squared being 64. And then just for kind of a housekeeping purpose here, instead of writing the 2.5 at the back, I'm going to write it in the front, but the square root will be gone, so it'll just be 2.5a. So then from here, I'm going to do my division, 64 divided by 2.5, and I'll have my acceleration value. So in this case, 64 divided by 2.5, I come out at 25.6. But again, making sure that I get my label, acceleration is in meters per second squared. And I've answered my second part to that. All right, Blessing, give me a thumbs up if that makes sense. Good morning, Ms. Parker. Thank you for joining us today, everybody. We got Ms. Parker watching. She's kind of seeing how this is all working. All right, so Zaria, I'm guessing problem number 59 is coming from the actual review section. Give me a thumbs up if that is correct. 640 review. Okay, excellent, excellent, excellent. All right, so I'm looking at problem 59. Okay, so we're going to page 640, everybody. Looking at problem 59. All right, so here we go. So in problem 59, we're asked to simplify the expression, and they're giving us 16, or excuse me, 1 over 16 to the 1/4 power. Okay, so there's multiple ways that we can handle this. Now, many people maybe feel a little bit more comfortable changing this particular expression back to a radical notation and simplifying there. But we can also simplify it from this position. So I will consider both of them. All right, so as I do this, let's start by what maybe is a little bit more familiar. So let's go to radical notation. So if I were to convert this to radical notation, I just have to keep in mind that my denominator within the fractional exponent becomes the index value when I change to radical notation. So I could write it in this manner. So in radical notation, I would say it is now the 4th root of 1 over 16. Now, in this particular case, if I write it in this manner, then what I can do is I can go ahead and I can break down 16, but I'm going to do that along with one other step at the same time. Now, keep in mind from radicals that if I have a root of a fraction, properties of exponents allow me to actually split them and write individual roots. So I could write it as the 4th root of 1 divided by the 4th root of 16. And now what that allows me to do is to simplify the 4th root of 1, which is very, very nice. That's just 1. But I've got to consider the 4th root of 16. Now, the 4th root of 16 we should recognize we could write as 2 to the 4th power. So we're essentially looking at the 4th root of 2 to the 4th power. Well, here again, the 4th root offsets the exponent of 4. So our result would be 2. So we would find that our answer is 1/2. Now, another way that we can do this is if we leave it in fractional exponent notation. Okay, so if we leave it in fractional exponent notation, what we would want to look at is the 1/16 here. So in this case, 16, we already know is 2 to the 4th power. So I could start this by saying the following. 1 over 2 to the 4th power. But since I have a 1 here, I can look at that as a 4th power as well. And I'm not affected here because 1 to any power is still 1. So what this would allow me to do, now keep in mind that I still have that 1/4 power that's acting on the outside here. So now I can use the property of exponents here that in this particular case, the exponent on the outside would multiply with the exponents individually on the 1 and the 2. So what would that be? In both cases, it would be 1/4 times 4, which is 1. So I would get 1/2 that way as well. All right, Zari, give me a heads up or give me a thumbs up if that makes sense. And Cindy, looking at your question, you thought there was supposed to be 4 of 1s that to take out? And yes, there would be, because I could consider here that 1 would be 1 to the 4th power, because 1 to any power is still a 1. Okay, so you'd be safe just in that regard. Okay, Zaria, looking good. All right, any other questions that we want to consider? And again, thank you, Ms. Parker, for coming on in. It was good to see you. Okay, this is your time, everybody. Okay, so we're looking at 83. Review again, I'm assuming. Give me a thumbs up. Okay, staying on the review, looking at problem 83. All right, so in problem 83, we have in this one, so again, it's an application problem, so I've got a little bit to write down as I read it. So we've got time in seconds required for a pendulum to complete a back and forth swing. I'm guessing you missed our review last Friday, whether it was some issues on that. And then Grace, we will hit 84. We did, but if they weren't able to be here, we'll just cover them real quick again. Okay, so don't worry about it, Chung, we'll be all right. Okay, so in 83, we've got t is equal to 2 pi times the square root of, I believe that's an L. Yes, it's a capital L divided by 9.8. Okay, so very quickly here, as we look at this, so L is a length of the pendulum. I believe that's in meters, if I'm not mistaken. T is time in seconds. And the rest is all good to go there. So now it says, estimate the length of a pendulum that completes the back and forth swing in 2.5 seconds. So the 2.5 is going in for T. So our goal here then is to solve for the L. So notice in order to do this, I need to get rid of 2 pi first. Now, one thing we want to keep in mind as we do it, I don't think I want to use pi as 3.14 because that introduces a little bit of error. So I'm going to wait until I have L all by itself before I throw things into my calculator. So in this particular case, the first thing I'm going to do is get rid of 2 pi. I'm going to do that by division. So that would say the following. So 2.5, we'd be dividing it by 2 pi. That would now be equal to that square root of L over 9.8. Okay? Then from there, now we can square both sides. That will eliminate the square root. So now we've got L over 9.8 is now equal to this 2.5 over 2 pi, and that whole quantity is squared. So our last step to finish this then is to multiply both sides by 9.8, reduction, reduction. And now we're left to just throw this into our calculator and do it exactly like this. So if you're using the iPad calculator, you'll have everything set up in its correct form in order to calculate it correctly. All right, Zara, does that make sense? This one's for Rose. Hi, everybody. Excellent, excellent, Zaria. Okay, Grace, you said 84, so let's take a look at 84. So again, this one was one we did cover last Friday, so that's okay. It's nice to see it real quick a second time, doesn't hurt. Okay, some of us weren't able to join. And also keep in mind, everybody, it brings up a good point, is that after this live feed is done, I actually will then keep that in, and it stays as an upload on YouTube. And so what I do is I set that up as a playlist then. So if you go under my YouTube channel, you'll see there's two playlists. There's one that would be for pre-calculus and one for advanced algebra 2. So if you've missed a section of this live feed, you can always go back and you can kind of walk your way through it, okay? So that's another option for you as well. All right, so looking at 84 real quick. Okay, so again, in this one, we've got a tetrahedron, which is a triangular pyramid with 4 congruent faces. The side length, S in meters of it, is given by a formula. So they're saying that the side length is equal to the following. It says it's 6v times the square root of 2, and all of that is raised to a 1/3 power. All right? Now, in this particular case, when I consider the side length, S is equal to the side length, label is meters. Okay, so I'm writing the labels down over there, so I just keep them in my mind. And then from here, the V is the volume in cubic meters. Cubic meters, essentially m to the 3rd power. All right, so in 84, it says, what is the volume when you have a side length of 8? Okay, so notice that I can put the side length of 8 in here, and I now have that equal to 6 times the volume times the square root of 2, and all of that is raised to the 1/3 power. So now my goal is to work towards V, so I have to work my way from outside in, eliminating pieces as we go. So the first thing I need to get rid of here, I need to get rid of the 1/3 power. Well, think of that like a root of an index value of 3, or a cube root. To undo that, I could change to root notation. I don't need to. All I need to do is think of the number that I can multiply with 1/3. That makes it a 1. I'm going to multiply by 3. The index value and the power would reduce then on that multiplication. So keeping that in mind on the other side, multiplying by 3, or excuse me, raising it to the 3rd power, now I could go ahead and actually calculate 8 to the 3rd if I chose. I'm going to leave it alone, though, because I can type it all in at the end. So that would say 8 to the 3rd power is equal to 6 times V times the radical 2. Now, some of you might feel a little bit more comfortable. So let's just look at it real quick. 8 to the 3rd power is not too bad. Okay, so 8 to the 3rd power, I get 512. Now, over here, I'm going to bring the 6 and the radical 2 together. So I'm just going to write it as 6 radical 2 times V. So now all I need to do is divide by 6 radical 2. So my volume then would be 512 divided by 6 radical 2. Now I need to be very, very careful here when I type this into my calculator. I need to make sure that I'm using that fraction key, okay? So when I do this, I want to make sure, I'm going to kind of show this up here if I can. It takes a little bit to get in there, but I want to make sure that I'm showing that fraction key. Okay, now it's not very clear. There we go. Okay, notice I'm going to use the fraction key here. So as I do that, then I can go ahead and type it in exactly as I see it. And I'm going to type 6 and then radical 2 on the bottom. So when I get it typed in here, hopefully that's going to focus for you here in just a second. You can see how the 6 radical 2 is on the bottom. Okay, I know that's not perfect. It's not. There we go. There we go. Okay, so see how the 6 radical 2 is on the bottom. That way, then when I go hit my equal sign, I now will get an accurate answer. I'm getting 60.33. So again, they're rounding it to the nearest tenth here by direction. So I would say 60.3, and then making sure I'm dealing with volume, get my label of meters cubed. And there would be my answer for 84. Okay. All right. Any other questions coming in? As other questions are coming in, Cindy, I'm looking at your question. In that particular problem that you're considering, we don't have to, because when you consider a fourth root of 1, 1 is a very nice number in this case. So notice the fourth root of 1, we're going to be able to say is 1. Now here's why. Because if I do 1 times 1 times 1 times 1, the result is still 1. So the beautiful thing with a 1, it doesn't matter what we have. 1 to the 4th is equal to 1 to the 3rd is equal to 1 squared. That's still equal to 1. So in that particular case with the 1, I don't need to generate another set of them. Okay? I don't have to do that with a 1. Everything else, though, I would have to do that with. Okay. All right, so any other questions that we have coming in? And Cindy, give me a thumbs up if that makes sense to you now. If it doesn't, then I'll talk to you kind of individually if there's a way we can do that, okay? Keep them coming if we've got other questions. All right. All right, I know there's a little bit of a delay here. So if there isn't anything more coming in, give me a little indicator that you're doing okay. So if you're feeling ready for this test, please give me an emoji with a smiley face on it, and then we'll continue with some directions for the exam from there. So let me know if you're feeling ready for this with a smiley face emoji. "33 people in the room today, everybody. That's pretty good." All right, so people, hey, Jatan, how are you? Excellent, excellent, excellent. Okay. So it looks like we're ready to go with this exam. All right, now, the exam itself has not been posted yet. Okay, I've got the test portion marked in materials. So what's going to happen after we're done with the live feed here, where you're going to go is you're going to go under materials. Okay. You're going to go to the Unit 5 folder. Okay. You open the Unit 5 folder, you'll see where it says Review and Assessment, and you're going to scroll down. Now, once you get into the Review and Assessment, there are going to be 2 learning targets, Target A and Target B. Okay, so what's going to happen is Unit 5 Assessment, Target A. what that's going to have is that's going to have a specific download for just that target. Okay? And then the same thing is going to be in Unit 5 assessment. In target B. Okay? So you're going to download two things here. The reason for that, because in the grade book, since we've done target assessments as individual pieces, we're going to take them as two separate targets here. Okay? So you're still going to have the same basic time limit as you would for any normal test if we were at school, but it's just in two pieces. Now, here's where we get, this is why this is occurring, because when you finish the first learning target and you're ready to upload it to Schoology, you're only loading target A to the target A test portion in Schoology in the gradebook. You'll do the same thing with target B. All right, so give me a thumbs up if that makes sense. Then I'm going to move on to the next piece. Again, as the thumbs up hopefully come in, these will be posted here as soon as we are done with the live feed, and then we will move ahead from there. Okay, so it looks like we've got them coming in. That's excellent. Yes, Lur, you're going to be taking both of these targets assessments today. Okay, that's what's going on. Today, you'll have time for both of them. Okay. All right. Now, this is more of a question. This is more of a deal of housekeeping. This is going to help make it so it's easier for me to get these things graded. Now, I know many of you are pretty good at being able to download the document, pull it into Notability, and taking the quiz or the test in Notability there. And that would be the preferred way to do it. Now, if you don't do it that way and you prefer to take it, say like by pencil and paper, and you choose to download the test, print it off, and then take the test that way, that is perfectly fine as well. But I am asking you of one simple favor, is that once you're done with that test, and this is if you're taking it on paper. Okay? So if you're going to do it as a paper exam, essentially, this is what I'm going to ask you to do. Okay? I want you to go ahead and take a picture of each of the pages. That's perfectly fine. But please do not upload them as individual pictures. What I'm going to ask you to do is pull those pictures into Notability and then organize them, okay? So in other words, page 1, page 2, page 3, and so forth. Okay, now the reason for that is that when you upload individual pictures, then I have to click back and forth between those individual pictures in order to grade them. And it ends up leaving a note on one picture, then I got to leave a note on another picture in separate spots. If you upload your pictures into Notability and organize them so it's all one document, then I can just scroll and I can leave notes for correcting purposes right there where you can see them all in one spot. You don't have to search for them, and neither do I. Okay, so if you are doing it pencil and paper, perfectly fine, but take pictures of those and then pull those into Notability, organize them before you upload it to Schoology itself. Now, if you do it on paper like this, please make that picture as big as possible. In other words, if you're using your iPad, fill the screen of the iPad when you take the picture of it, okay? That way it just makes it all the much easier for my old eyes to be able to see it and correct it. Okay, so those are the two major things. If you're doing it in Notability and taking it in Notability, perfect. If you're doing it pencil and paper, take pictures, bring them into Notability, organize, and then upload it to Schoology. So you have two of these. You've got a target A and a target B. All right. Yes, Zari, you can do it that way. If you've got a printer at home, I would even suggest printing the test out and then doing it that way. Okay? Anything to help keep it organized. So if you do have a printer there, print it out and then do the work. But yes, you can take a picture and upload it. But again, bring that into Notability. Keep everything organized so I can tell exactly where everything is at. Okay? Give me a thumbs up if that makes sense. Okay, got it from Quan. How about you, Zaria, for your question? Does that make sense for you? Okay, looking good here. All right. Okay, so it looks like we've got all thumbs up coming in. So at this point in time, everybody, we are going to look at getting this test underway. So you can come back to Schoology real quick. I'm going to put it at 11:40, and I'm going to give you 2 hours. Okay, so you'll have 2 hours to complete both of these assessment pieces and get them uploaded to Schoology. Okay, there's not a huge number of problems. It'll be just like a normal test that you've seen, but you'll have 2 hours. So the testing window will close at, let's see, it's 11:40 that will do it. The test would close at 1:40, okay? But I'll even be nice. We'll say we'll close it at 2, okay? Does that work for everybody? Okay, so again, let me put this up here, how this is gonna work. Give me thumbs up if that makes sense, from 11:40 to 2 for both pieces. So again, because I know that you've got to deal with the technology piece of this. So the test start is 11:40. The test end, I'll have set for 2 p.m. Okay, so essentially you have a little over 2 hours to get this done. Okay, now I will know if you submit late because I have a deadline at that as a point in time. So if it comes in after 2, I will know. Okay, so make sure that you are staying up to speed on this. And again, I am asking your honor here. Okay, I have no way of being able to check that, but I do ask that you try to make sure that you are looking at how you are doing on this material. So let's make sure we keep ourselves honorable as we take the exam. So at this point in time, everybody, I'm going to wish you good luck. You all have this. You've all got to do this, and you're going to do well. Okay? Give me 5 minutes. It's 11:36 right now. I've got about 4 minutes to get the 2 pieces posted, and then you'll be ready to go. So if it's a little later than 11:40, we'll still be okay. You'll be done by 2. Okay? Have a great day, everybody. Take your time. Keep it neat. Make it look good. You're going to do great. Have a great afternoon. And also keep in mind there is no live feed tomorrow because you've got a new section that you're going to be working on. And that will actually go into quarter 4 grade. But you got a new section there, and the section does take a little bit of time. So you'll be a little busy on a video. The video ended up going over an hour. So if you need a little break from it, take a little break. Come back to it a little bit later, whatever you got to do. But anyway, let's get on our way, everybody. Good luck, and I'll see you on Wednesday. Take care.